Hi there, Andrew Jackson, AJ Design Studio. Today I've got a video covering a chair that I've pulled out of the archive, something that I've sort of struggled with modelling, and this has taken a few years actually to realise the final version of this. So this is the Belleville chair by the Bouroullec brothers for Vitra, and it's an exercise I started in 2021. I selected this because of the form. It's quite an elegant chair and also simple but with complexities, lots of blends going on. So yeah, as I said, I kind of got stumped on an area around the front, so I kept giving up on it and working on sort of easier things. But I've decided 2025 is the year of going through all my half projects and finishing them. So my intention originally was to look at this and try and figure out line of draw and part lines and all that, but it's just too much of a mission to try and figure out because I don't actually have the chair here as a sample to check, to see where the actual part lines are. So instead I've just focused on modelling the parts and completing the main blends on the seat frame underneath. So as far as references for this, I only had two references, one of them being the CAD model that's available on the Vitra or one of their partner sites, and that's fairly coarse, and the other reference is the Vitra website. So this model here looks a bit nicer than the one you can get a mesh for, but you can't download this one unfortunately, and you can't pivot right underneath. It's got some locks there, so this is quite handy for trying to look at the back here. So this is my best attempt at creating this chair. So I'm going to do what I normally do with something a bit more advanced like this. If we have a look at the performance evaluation, so 427 features, I'll roll through the tree, and if I just show you the directory with the files, so you can see here started 2021, and then had another go in 2022, and then 2023, and then I've really had a run on it over since the beginning of this year. So as I said, this area at the front where I was struggling, I'll explain that when I get to it. I'm just going to roll back through the tree. I might take some fairly large jumps past some of the stuff which is sort of fairly like trims or stuff that's not too critical. I'll upload the file too, like I normally do, so you can download this and pick it apart. Solidworks 2020, so it's a bit more accessible. First things was I created this draft control, but I haven't really used much that. So I'll just bring up the mesh. I trimmed the mesh in half in Rhino. So I've started by creating the center lines, some geometry there, sketch geometry, fairly simple, like degree 2 curves, and then I've created a sweep, which is that main seat surface on the underside of the seat pan, and then created a back section. So the rear section there, this is the loft, because it changes section as it goes up, and then I've extended those out to intersect them out this side and trim them back just to square that end up. And then I've proceeded to trim those surfaces back for where I want the sort of bottom area or the rear of the seat to run through. And then I've created some curvature continuous degree 5 style splines through there, so those got 6 CVs, Bezier curve, and those are curvature continuous to the references, and then created a boundary surface. So that's the main seat sort of shell construction. It's a bit wobbly out here, but I'm not worried about that because this gets trimmed back. So I've overbuilt this surface up here and this one because I'm going to come in and trim this back. That's the back trim. And then last of all is this trimming through the blend that blends the back and the seat together. And that is I've only made a tangent blend there. I could have made that curvature continuous, but I haven't. So anyway, approximated the form from the mesh, and then I have thickened that a normal amount. Sorry, it keeps hiding. Okay, so thickened that out, and then put a big fillet on the front. Okay, so that was easier to overbuild this and trim it back than rather than explicitly define this boundary here and then build surfaces, because otherwise the UV flow on the surface here would be narrower here. So instead it's just more open and easier to do. Easier to get a nice result. Next up is the front leg. So with a chair like this, I sort of work the base forms. Any chair I've worked on, actually, it's the way to try and do it, is to get everything in place first, like your base geometry, because that's the stuff that drives the blends, etc. And also if you're trying to work for designing it for manufacturer, then that allows you to build the base geometry to suit your draft angles, etc. So this leg it's an elliptical form, and it is extruded upwards, and then I've got some draft on it to give it the taper. So it's got half a degree of draft as it runs up. And then the rear leg, I've only run it up to this area here because there's a big blend that goes on in here. So I just wanted to define that area. And the rear leg is a 3D curve there, which is controlled with a couple of projections. So those are projected onto each other to control the center line for that extrude onto the arm. So this is getting a bit more involved now. So the arm, actually, the elliptical section sort of rotates as it comes through the nublet of the elbow. So I've had to create these two base forms. Again, the geometry here, they're both lofts. 3D sketch there. So if we have a look at this one, see if it's center line. Okay, so it's a center line loft with two sections on each end. Sorry, with one section on each end. Okay, and then this one up here, again center line loft with a section on each end. Okay, so this is where it starts getting a bit trickier, because I had to define a whole pile of geometry here to control this form as it sort of flows in space and rotates. So it didn't pinch, because it was pinching at one point in here. So those are a series of 3D sketches, and those are all dimensions. So that's actually a degree 6 style spline here. So each end is curvature continuous to some reference geometry. And then I have a free point in the middle, which I have used to reduce the pinching and give me a bit more tweakability. And then I've also added an elliptical section through there as well. And then that's finished off with the boundary surface. Right, moving on, otherwise this video is going to be really long. Next thing to do was to start populating the seat frame on the underside. So I started building the seat frame front. So I've got some offsets in here. So this is the underside, which I decided was going to be an offset. I don't know if it is in reality, if it's an offset of the underside of the seat pan, but I decided to do that anyway. So that's 30.5 millimeters. And then just a few trims, and we start building, we'll hold the top there, start building the side walls of the under seat structure. Okay, so those are sweeps, and they're just intersecting, they're all arc sweeps, swept arcs. And they all intersect through the underside surface. and I've trimmed those back. I've got a few things you might see if you're rolling through the model. Like I've got a tool body, which is basically when I've had to copy a surface to extend out to build an overbuilt surface. So anywhere it says a tool body, that's just a copy of a surface, which then gets manipulated just to drive other surfaces. So next up I start building some of these side fillets that run around the underside structure. So in this case you can see that's not attached. So what I've done there is it is a double hold line curvature continuous fillet. So I wanted to define these lines here. I wanted the fillet to run from here to here explicitly. So I've defined those lines via split lines by splitting those faces curvature continuous, and then you only get one chance to pick this option, which is in a face fillet. When you create it, you can pick to don't trim or attach, which creates it as a separate surface so you can continue to manipulate or extend it without actually trimming back your input geometry. But as I said, you've only got one chance to do that, which is when you create the fillet. You can't go back in and change it once it's made. Okay, and then there's the front and back underside fillets. But in this case, this fillet here and the rear one, they are not hold line fillets. This one's asymmetric, curvature continuous, so I've got 2 dimensions there. And then I believe the front one is a chord width. So the chord width being the distance between the fillet rails. Okay, so those are all unattached, as you can see. Okay, then there's some trims, delete face, yep. And I've cut back a section here from the back of the leg, because this is where the blend's going to start going on. You can sort of see what might be starting to happen here with this, where that ends. It's all going to blend together. So next up, front leg blend. Here's some of these tools I mentioned. So I've got an offset surface as a tool, and you can see how big that surface is. So what I'll do is just go down here and we'll show those tool bodies, and I'll show the blend. So originally I'd been trying to build this surface in here, just running it to the same height as where that fillet terminates, across here like this in this model here. So I was trying to build the surface here, and then I was trying to block in surfaces through this area here, and I was having continuity issues and just general flow problems. So this is the area that stopped me working on this like each year, until I just sort of sat back and had another think about how to do it. So we'll just jump back to the other model. So as you can see here, I've got a big overbuilt surface. So with this surface, the theory being we are going to trim this. So this is going to get trimmed out. So I know I've made this massive surface and I've got a tool here, but the thing is that if I turn on curvature, then I've got a really nice flow all the way through here and into the leg. So I don't have to worry about trying to patch in things, and I don't have to worry about how I'm going to terminate like a pointy 3-sided surface or 3-sided hole. So this is a much more robust way to do it, and I'm doing the same over this side. So I'll just roll forward. So that's the other side blend. So I've got the 2 side blends in place. I'll just hide these tools now. So next up is there's another surface that I have to create at the back, which is called the mid surface. So I'll just hide these blends as well. So as you can see there with the mid surface, it's running from the underside structure, and again this is a large surface which will be trimmed back, and again I've overbuilt it just so I've got this, I can trim it back how I want, and I know that it's curvature continuous spanning between the leg and the underside of the seat structure. Okay, so next up I'm just going to trim these back roughly with each other, so I can sort of see where like the theoretical edge intersections are, just to help me when I'm sketching out the blends, or the trims for the blends. Just doing some stuff here just to trim back the fillets. Okay, now we're going to start. I've got a sweep down here which gives me some geometry to try and run some trims onto these and these, because I basically want to, now I've built these, I know this is all smooth through here and smooth through here, but now I've got to transition this fillet here down into this area. So I have to trim these primary surfaces back to give me my secondary surfaces. So if I just jump forward here, so you can see here, I've trimmed those right back. And there's various bits of geometry in there that control my trims. So I've got a sweep running down here, which gives me a nice constant offset here. And then I've got sketches and planes at funny angles, because these, you want to trim from a suitable angle so you can get a nice tangent on each end. This end here, big thing, never like this is if this was 90 degrees, then this edge here would run in tangent into that, which means you run into the problem of that edge there might disappear. It might not, but even if it doesn't disappear, Solidworks doesn't like it, and you can quite often end up with crinkles. So if you're doing something like this overbuilt surface, don't take that down to zero, to being tangent with the other edge there. So that trim there is 91 degrees, 1 degree basically of difference at the end. Only found out that through crinkles on my surfaces there. Okay, so then I've got these blends. These are big, what I call secondary blends. I have a series of like a 3D sketch which controls planes and some cross curves. So these cross curves, I'm just going to explain at once. They're all degree 5 style splines with 6 EVs and curvature continuous at each end to intersection curves through these surfaces here. So that's the same across all the blends I do with these secondary blends right across the model, including at the back. And that's a boundary surface. So boundary surface is tangent to the main, the long axis, 100% tangent influence, and then we're tangent at each end here as well, and also on tangent influence 100%. And then I've got my second blend on the other side, which is constructed in the same way. It's a little bit different because this side fillet here is a lot, it's got a bias in its size, as you can see. So end result, it's a bit coarse in here. This is just the zebra in Solidworks. If you think the zebra looks a bit coarse here in Solidworks, I'll put this all over into Rhino at the end so you can have another look. So there's those blends at the front there. So that's the front leg completed. So just big overbuilt surfaces basically was the way forward. So now the back is like an extra level of tricky, because we've got this section through here which has to blend into the underseat structure. So this area here, we're building the rear junction mid, which is this, building the surface here, and then deciding where to split the surface, because we're going to delete this part here, because we're going to run curvature continuous surfaces from here through to here. So it's, yeah, I've got controls in there to control where this point goes, because if you move this a little bit, anything that runs curvature continuous surface off there, it has quite a great effect on it. So it's needed for fine tuning to have control over that line on the front and back of the rear leg. Okay, so I've started building my overbuilt surfaces, as you can see. The back here, if we turn on the reference mesh, it's quite complicated. Just blur your eyes a bit, squint, and you can you get the general feel for this. So this is running underneath the surface here, and by the time it gets around to here, it's running the other direction. And so this surface here has to come around and then lift up to meet up with this edge here, while also blending between this face here and this face here, and the same on the back, while also addressing how these fillets run in. So quite complicated. So this time I've created something a bit, how would you call it? Instead of making planes, I've just created these extrudes, which I can control from a sketch here. So I can control where these surfaces, which are used as planes to sketch on, lie, and then I've created sketches on those surfaces. It was just a simpler way to set this up rather than having lots of planes and stuff like that. And then those sketches control this overbuilt surface here. And then we've got some more creating tools for overbuilt surfaces again. For this surface down here, I have got this, where are we? I know that's for later. Anyway, I've created this bottom surface in the same manner as the top one, and if we put our zebra stripes on, you can see what's going on there. So it's blending out of the leg, running around and into the underseat structure, and on the top it's just running around to being horizontal at that point. Okay, next is the rear junction back. So again, massive big overbuilt surface. The tool for that is up here. So pretty much the same as the front. I've spanned between that tool body and the surface here with a giant surface, and that has 3 sections controlling it, the most critical being through here in the middle. And end result, so running fairly smoothly out of the back face of the underseat structure. Okay, next up is trimming that back. So I've trimmed that back to sort of, again, give me a rough idea of where the theoretical edge of these two surfaces are, where the intersection is, but because they don't actually intersect in a nice manner, I've just trimmed them sort of arbitrarily. So I've got something, roughly a visual reference to know how far back to trim things, or the curvature of the trim, to get a nice blend that isn't biased heavily to one side. Okay, so trim back to expose that fillet, and then a whole lot of other trims like that, if you want to have a look at those. So again, sketches, sometimes on sort of arbitrary planes, other times not, and again, yeah, it's all dimensioned. And like the front sections, this is a boundary surface with some cross sections in the long axis to give me a nice flow. Like that. So this is a tricky area on the actual product. If you look at it, you can see the highlight that runs down the back of the leg. Carries on sort of fairly uninterrupted through this area. So that means this surface, I think it almost runs around and there is a bit of negative curvature on this face here, as you can see. Okay, so that's the back blend there, and then it's onto making this little surface up here. So it's called the hip small blend, and that is basically got a rolled surface here which is taking tangency off another surface, and then a sweep to trim back this edge here. Hang on, let's have a look. Okay, so that sweep gives us a nice equal distance, like if that's the rail and the sweep is touching over here, it gives us a nice equal setback for the blend. And then down here we have the top blend. Okay, secondary blend. So this one's a bit trickier because that obviously comes down, it hooks up. If we look at look at our reference here, you can see it comes down around and hooks up under the seat pan. So again, that surface has multiple sections controlling it, as you can see there. Right, so that's the rear of the rear leg blended in. Now it's the front bit, which has got its own sort of tricky areas. So first up, let's create a giant primary blend there from the surface to the outside of the leg. Again, you know, nice big sort of open flowing surface. And secondary blend bottom, so that gets trimmed back. We've already got our underside primary blend there, which has been trimmed back. So now we just trimmed everything back and put this big surface in here. So that was a little bit tricky at first. I didn't know where to terminate this area here, but it all sort of worked out. Okay, so again, this is built pretty much like the front under here, except a little bit more complexity, and several cross sections across that blend to control the fullness of it. Right, and now the top blend. So this is where I sort of also got a little bit stumped, because the surface goes from being undercut to being the opposite direction. So I was not entirely sure how to do this at first, but I thought, okay, let's just break it up, kind of like I broke up the back surface here. Build this surface here, and then we can just finish this area off separately. So again, this surface is treated in the same way as all the others. Knitted that all together and created this secondary blend at the front, with a few cross sections that are curvature continuous to the surface, to finish it off. So that means the surface, you know, we get to transition, it twists as it goes along here, from undercut to over. And then last but not least was finishing off or extending this surface out here. Just cap that off, even though there's a fillet that runs around here, sort of erodes most of that surface back like that. Okay, so next it was on to just some basic functions. Solidify, so create planar surfaces wherever there's holes on the center line. Extend the legs down to the floor plane and trim them back, and knit everything together and thicken it to give us a solid seat frame. And create the glides. which is a split those bodies apart, put a fillet on it, and I thought I'd add these underside details too because they're quite prominent, and because they're a lozenge form I got to use my my Clothoid Apple Watch 6 button setup. So that's that. So that's the underside. And last thing was the seat. Top of the seat pan actually overlaps into the back of the frame. So I created a cutout for that. With a little offset gap there. And added fillets. And mirrored everything across. Combined the bodies that need to be combined and ran a body delete keep at the end just to keep our solid bodies. So there's the end result. That's the Belleville Armchair from Vitra. I'll take this over to Rhino so we can run a zebra analysis on it with a finer mesh so we don't have as many jaggies. Okay, so here we are in Rhino. I'm just going to change the default mesh. Okay, so this mesh is a bit finer. So the seat pan, that's all good. Zebra on there. I know the arm looks a bit funny through here. Looks a bit sort of flat. But I've done quite a bit of comparisons with the photos and their model as well, and that's kind of what happened. So it is what it is. The blends on the underside. There's a few little glitches here and there when you look at it with a super fine mesh, like through here there's a little crease, but way better than my first attempt, which was as I showed you. Remembering this chair, like most chairs, have fairly heavy textures on them, so little wiggles and wobbles probably, oh there's one, probably aren't the end of the world. In fact, I know they're not the end of the world because I've worked on several chairs that have gone to production, so you know, it doesn't really matter if there's like a slight discontinuity. It's more about the general the gross flow of the surfaces, and I'm guessing these frames are probably molded with gas assist so they don't core out down inside the leg. There'll be some sort of void created in there via a gas process. So anyway, all looks okay. Nice shiny environment map, which kind of hides a lot of, you know, this is more like if it's got a sort of a coarse texture on it, more representative. So I'm going to wrap this up. As I said, I will put the model in the description if you want to download it. Sure, there's probably other ways I could have, you know, instead of making giant blends, overbuilt surfaces, other ways to do it, but it definitely, you know, it got me stuck out of a sort of sticky spot, especially around the front here. It's quite complicated. Yeah, anyway, thanks for watching. Andrew Jackson, AJ Design Studio. See ya.